Hello, for section 3.3, we're going to go over factoring and we're also going to go over square roots. For this one thing you are going to need to know is how to simplify a square root. We talked about it a little bit last time. So if we have the square root of 27, that could factor into 9 and 3. And then the 9 can factor into 3 and 3. When you are simplifying a square root, you are going to find pairs of 2 that can go outside of the radical. So for this one, we would end up with 3, and then anything that doesn't have a pair stays underneath the square root. So it would be 3 square roots of 3. Then our next one, if you get a fraction underneath the square root sign, you are going to simplify it by finding the square root of the top and then the square root of the bottom. We don't want to leave any square roots on the bottom, so you can rationalize it by multiplying both the top and the bottom by that square root, or you can just simplify if possible. So this one, the square root of 36, would end up being 6. And that gives us our most simplified answer as the square root of 5 over 6. Okay. So we're going to go over the square root method first. So one thing that I'm going to reference in this video is the flow chart, the quadratic flow chart. With that, I'm going to pull it up really quick. I should have done that first. We're going to use the flow chart to determine which method we are going to use to solve a quadratic, because there are a few different ones. Okay, so for this, we are going to start off with, we're going to split view with that. Okay, so for your flow chart, it begins at the top of this paper here, start. And I do have a copy of this on Schoology, or you can get a paper copy in class. So you're going to start off with, and you're going to check, can the equation be written in the form of x squared equals k? What that looks like is either you're going to have an x squared value with a coefficient, and then you just have a constant or another value that you can get all onto one side. Or it's going to look like if you have a set of parentheses with an x plus or minus any number in parentheses squared, and then we have a constant out there. When you have those two scenarios, you are going to go to the yes. That means you are going to solve using the square root method. That's what we're going to do on these first 3 examples. When you are solving using the square root method, you are going to first isolate the squared value. So in this one, our squared value is this parentheses. So we need to get, we need to get that set of parentheses by itself. We need to get rid of that 1/2. To get rid of 1/2, you multiply by what the denominator is. So we're going to multiply both sides by 2. That will leave us, because these will simplify to be 1, so we don't need them anymore. That will leave us with x minus 2 in parentheses squared equals 16. Once you've isolated that squared value, which we have, the second thing you're going to do is you're going to square root both sides. So we're going to take a square root of x minus 2 in parentheses squared and the square root of 16. When you do that, when you have an equation and you take the square root, you are going to get a positive answer and a negative answer. So you're going to get x minus 2, the squared and the square root simplify with each other. And then when we take the square root of 16, we're going to get a positive and a negative 4. Our goal is still to get x by itself. So your third thing is to then finish solving for x. So on this one, we would end up adding 2 to both sides. Now, when you have this, we would end up with 2 plus or minus 4. If there are no square roots that are left, or no imaginary numbers, you are going to separate this and solve. So one of them we're going to add, one of them we're going to subtract. That's where we're going to get two different answers. So we'll have x equals 2 plus 4 and x equals 2 minus 4. Then we simplify. We get x equals 6, x equals negative 2. Those are our final two answers. All right, looking at our next one. We have 5x squared minus 30 equals 70. So if we go to our flow chart, the first box where we're going to start, can the equation be written as an x squared equals a constant? This one, it can. There are no other x terms other than that x squared. So we're going to start by isolating that x squared value. So we'll add 30 to both sides. That will give us 5x squared equals 100. When you're isolating that, first you do the adding and the subtracting, then you have to get rid of the coefficient. So then we have to divide by 5. Do not take the square root until you get the square term by itself. So you would get x squared equals 20. Now we have isolated the squared value. We're going to take a square root on both sides. And when you take the square root on an equation, you get a positive answer and a negative answer. So we have a positive square root of 20 and a negative square root of 20. Every time you get a square root, if it's not a perfect square, you still need to make sure you are simplifying where possible. So 20 can factor into 5 and 4 can factor into 2 and 2. So that gives us a group of 2 and then a 5 left over. So for our final answer, we would have x equals plus or minus 2 square roots of 5. Now, because this one has a square root in it, we do not need to simplify any further. So we can just stop there, and it's okay as long as you keep this plus and minus in front of it. Okay. Our next one, we have 1/3 times x plus 7 in parentheses squared equals 8. So this one, if we look at our flow chart, can be written with that parentheses squared equals a constant. So we want to get rid of this 1/3 in front. We're going to start by isolating that squared term, multiplying both sides by 3. That will bring us to x plus 7 in parentheses squared equals 24. We've isolated the squared term. This one just so happens to be the parentheses. Then we're going to square root both sides. The squared and the square root simplify and gives us x plus 7 equals the square root of 24. Make sure you do not forget you get two answers, plus and minus. And then we can do our factor tree. 24 can be a 12 and a 2, 6 and 2, and then 3 and 2. Oh, no, those weren't the ones I wanted to circle. There we go. So we have a group of 2, and then we have a leftover 3 and 2. Anytime you have more than one number left over, you are going to multiply them and then put it back underneath the square root. So I'm going to rewrite this over here. So we have x plus 7 equals, and plus or minus the square root of 24 simplifies to 2 square roots of 6. Then our last step, we need to solve for x. So for this one, we need to get rid of that 7, so we will subtract 7. When you have a number that has a square root, you are going to treat that number the same way we would treat a 2x. So 2x and negative 7 are not like terms. We cannot combine them. So at 2 square roots of 6 and a 7, those are also not considered like terms. We cannot combine those. So you're going to write your answer as negative 7 plus or minus 2 square roots of 6. Now, because this one still has a square root that cannot be simplified any further, we are going to leave our final answer like this. You do not have to separate it if you have that square root there, or an imaginary number if an imaginary one shows up. Okay, so that is how you would solve when you have the square roots that you can use the square root method for.